Okay, so today we're going to talk about applications of exponents. And it's honestly not really anything new. You've done applications, you've done these questions before. It's just that it wasn't framed in terms of exponents. So in grade 8, you were asked to find the area of squares. You remember what the formula for area of a square is? We talked about the other day. Length times width. That's for a rectangle, which is fine. But on a square, all the sides are the same. So I can go side times side. So area of a square is side times side, or written as exponent, side squared. All right? Now, if I asked you for surface area, you guys ready? All right?
I don't know how he made this in so because we're trying to tell him something. He made me that.
Ravinder, go pick it up. Let's focus here.
What are you doing?
You okay? You ready to go?
Yeah, he made it. I didn't make it.
Are we ready? That's not the question I'm asking
Yeah,
here.
we're ready. We're ready.
Thank you. Okay, so if I ask you for a surface area, what am I asking for? Caden, is that your hand?
Yeah,
Yeah.
wouldn't it be, if like all the squat sides were 5 centimeters, wouldn't it be 5 centimeters with a 3 exponent?
No, that would be like a volume kind of thing. Surface
Oh,
area?
not on volume?
Oh, sorry, that is volume, yeah. Yeah, so volume is your length times width times height. So if this was length times width times height of any rectangle shape, but if this was a square, side times side times side, which would be just side cubed. All right? So written as exponent form. You've done this before, we're just rehashing it as exponents. And the final one is the surface area of a cube. Yes, Logan?
It would be all the sides multiplied by each other, so 5 to the power 6.
5 to, no. Oh, sorry, these aren't 5s, these are S's. We actually use a different letter. But I see what you're talking about. Not quite. So surface area is the area of each side added up. So if a cube, they're all the same. So area of one side is this. And if there's 6 of them, it would be s squared plus s squared, or just times your answer by 6. Okay? And that was part of your assignments.
Wait, so it's an S, not a 5?
That's an S. Yeah, maybe I'll change to a different letter for next time I do these notes. Okay. All right. Now, you also worked with triangles last year. You remember the formula to find sides of a triangle? That was for area. I'm looking for sides.
Oh,
Yeah, a squared
When you like time.
plus b squared equals c squared.
Yeah.
Right? So that was Pythagoras,
Yeah.
right? And c was your longest side, known as your hypotenuse. Right? Across from that 90-degree side. Now, if you wanted to find one of the other sides of the triangle, they were called legs, you just said your longest side minus your other side was equal to, if you wanted to find one of your other sides, not your longest side. So, the one that most people had, at least with my grade 8s, the most difficulty was with the circle formula. If I asked you for a circle, the area of a circle, do you guys remember what it is?
I don't think we did this. I don't
Wasn't
know.
it 0?
No, it was pi.
Circle that.
No, I thought like the outside can't be measured of the circle, something like that.
Oh,
It
I
can
remember
be.
that.
Pi times r squared. You guys remember that?
Yeah.
No. R. You guys are in an oddball situation last year, so I don't know what happened. Right? When your teacher would have taught it. Was
I'm
it?
good at sheeps.
Right? So R, do you know what does R stand for?
Isn't it like radius?
Yeah. So radius is the distance from the middle to the outside edge. And what is the distance all the way across the circle called? No. Circumference is all the way around.
Oh.
Across is called diameter. And we usually use the letter D for that. Okay. All right. So those are some of the formulas that sort of pop up throughout the course. In grade 9, we don't directly do a unit on volumes and areas and stuff like that, but they show up in word problems. Right? So in this unit, they show up in word problems. All right? So let's do example 1 here. So you have a surface area of a cube with an edge length of 3. All right? So we have a cube. We want to find its surface area. Right? How big is the area all the way around? So we use our surface area formula right here. Surface area is equal to 6 times our side squared. Right? How long's our side?
3.
3. So 6 times 3 squared. Now we have to apply bedmass rules to say what our surface area is. So what do we do first?
Figure out with the exponent.
3 with exponent 2, what would that be?
9.
9. 3 squared is 9. We still have that 6.
54.
6 times 9 is 54. Now, with these kind of questions, we need to include units. What would our units be?
Meters.
All right? Meters squared. All right, area. Maybe we'll make a side note here. Okay? Area is always your units squared. So even if I ask your area or surface area, it's always whatever the unit is squared. Volume is just your unit, whatever your unit is, with a 3 exponent. Right? And if I asked you for how long a side is, your unit is simply just your unit. If it's 3 meters or centimeters or whatever it is, right? Okay. Come on. Next one. Find the length of a square attached to the hypotenuse. So we're looking for, oh, that's a bad color. We're looking for this distance here. How could we figure out what that distance is? Using some of these shapes. Carter?
Would it be 12 plus 9?
Carter says 12 plus 9, and which formula are you using?
The A plus B.
Is equal to C? Yeah, so you're on the right track. Now, this would be your side C, this would be your A and B, but it's not just 12 plus 9. Yes, Carter? Sorry, Caden?
Wouldn't it be 12 squared plus 9 squared?
Yeah. So C squared is equal to A squared plus B squared, and that was 12 squared plus 9 squared. And the A and B sides, you can interchange for your labeling. So we go, what does that equal? So you go 12 squared, so 12 times 12 is 144. And 9 squared, 9 times 9, 81. We add those together. So 225. So is C 225 centimeters?
Yeah.
Can I ask Siri?
Centimeter squared.
Okay.
What's
No?
144
No.
plus
So
8?
this is C squared is equal to 225. Not the side.
Oh,
So-
it's 15 centimeters.
Yeah, so you had to take the square root to find the side. You guys, so coming back to you slowly?
Yeah.
Alright, so then we take the square root, and you gotta remember how to do the square root on your calculator. So square root of 225, oh, that's not right. 225, 15. So C is equal to 15. Right? Centimeters. Right? Now, when you get to grade 10, they may take this question and say, hey, what's that perimeter of that square? They may add an extra step. You guys remember what the word perimeter means?
Like all the way around.
The distance around the outside edge, right? So what they're doing is adding an extra step on here. So if we figured out this was 15 and this is a square, you guys can handle this question now. You guys are a clever class. What would the distance all the way around the square would be?
15 plus
centimeters.
50.
Yeah, so 15 plus,
60.
yeah. So if I asked you what's the perimeter, you add all the 15s together. First side, second side, third side, fourth side, and Harinder got it right, is 60. So 15 plus 15 plus 50, right? That's a add-on question, right? But that's sort of how these kind of questions progress. Okay. Next up. So the next question shows a circle inside of a square, and it asks to find what is the shaded area. So all these corners, how much space do all these little corners take up? Does anybody think they have a strategy to figure that out? Did you do a question like this last year? Yes, Carter.
Maybe divide 16 by 2.
Divide by 16 by 2, and what would that give you?
Wait, I have a question.
That's okay. 8. Okay, so that will give you, what, half the distance?
Yeah.
So that might be helpful for the circle, right? That gives us the radius of the circle. Yes, Carter. Okay, then, sorry.
Would you need to find the diameter of the circle first? And then,
Well, the diameter, what would the diameter of this be?
16.
16, right? All the way across, right? So this is where we start piecing clues together in, okay? So they're asking about area. So chances are we're using area formulas, right? So what shapes do you see here?
Circle and a square.
Circle and a square. So we have an area of a square and an area of a circle. Somehow we gotta use these two numbers to figure out what the question's asking for. Yes?
Would you have to find the area of the square and then minus the area of the circle then?
Yeah. So if you find the area of the square, that gives you this entire box. If you subtract the area of the circle, so you're taking out that amount of space from the middle, all you're left with is with these tiny little corners. So that's the approach we gotta do. So we gotta do it in 2 steps. We gotta find the area of our square, calculate that out, and then we need to find the area of our circle. Once we have those 2 numbers, we subtract them. So, area of a square, you can find that from the previous page, it's just your side squared. So how long is our side?
16 centimeters.
16 centimeters, so 16 squared. So that one I don't know. Grab your calculator. 16 squared becomes 256. Area of a circle from the previous page is pi times r squared. Pi r squared. Right? So what is r? Radius, and what's the value?
8.
8. Right? If 16 is all the way across, 8 is halfway across. That's the radius. Now, the value of pi. There's a
1, 4.
right? 3.14, right? Times 8 squared. Now, you have a button on your calculator that has a pi. Pi is a number that just keeps on going on forever. And so at grade 8 and grade 9, it's fine to use 3.14 as a shortened form of pi. Once you get into grade 10, your teachers start asking using that button on your calculator. Is it a more accurate number? So at grade 9, whatever you feel more comfortable with. I'll take both answers. You can type in 3.14 for pi, or you can use that button on your calculator. Either way, right? So calculate this out. What number do you end up with? Right? So this is the hardest calculation. All right? Make sure you can do it. So I did pi times 8 squared.
What?
We
The pi button? Oh, I found it.
Yeah. Or 3.14. You'll notice that the answers are going to be slightly different. Right? So make sure you can do this on your calculator, right? Don't lose marks because you can't use your calculator. So I sent home an email to all your parents this weekend. They're asking to make sure that you have your calculators. I'm going to be checking them today. I'm going to put a little mark in the grade book so you can check, see if you have your own calculator, scientific one. So once we're doing our homework, I'll come around and I'll check.
Would we round up on the first decimal place?
So the question asked to round to first decimal place. So that should be 201.1 if you use the value of pi as in your calculator. Or if you used 3.14, should have been 200.96, or it would round to 201.0. So you would end up with slightly different answers depending on what value of pi you use, right? And our units, since we're talking about area, is our unit with a square. So our unit is centimeters, square. So either one of those answers, I would accept. Right? So when you're doing this, common thing that students will do, instead of going pi times 64, they'll do pi times 16. That's why I just wanted to make sure you're doing it correctly. All right. Let's just do one of these. These are pretty straightforward kind of questions, but students often have a lot of difficulties with them. So a path a skydiver follows this equation. And you get to learn about this equation next year when you're doing physics. Where D stands for total distance and T is time in seconds. Calculate the distance the skydiver falls in the following times. Right? So they're saying that for when time is 2 seconds, how far does he travel? All you're doing is using that equation and plugging in values. That's all I'm asking you to do. So our equation is D is equal to 4.9 T squared. Right? And you're given the value of time is equal to 2 seconds. So where you see the time, you can replace it with the number 2 in brackets. So when we're replacing variables, replace it with a number, put it in brackets. There we go.
Is it 4?
So that would be 2.2 squared. Sorry, 2 squared is 4. So you have 4.9 times 4, which would be 4.9 times 4. Oh, that's not right. Times 4. 190. Oh, that's not right. 4.9 times 4. Calculator issues. 19.6. Okay. So we're talking about distance. What unit would this be? It gives you a clue in the question. What units is this? How far did he fall? Is that centimeters, inches, yards?
Meters.
Meters. And the abbreviation for meters is a lowercase m. You want to do it for 4 seconds?
Wouldn't it just be double?
Let's do it for 4 seconds. Quickly do it. You guys can do it. I'll write up the answer. Just make sure you come up with the right answer. Oh. Right. 78.4. Right? Kaden had a good guess of saying, hey, it would be double, but the relationship is not that it's not linear, it's squaring. So it's actually, if you're doubling the number, you're going up by 4 times as much because you're squaring the difference. So 2 squared would be 4. All right? So just make sure you can do those things. So if I give you an equation, all you're doing is replacing a number with that letter and just calculating. Okay? I'll give you, this will be like out of 2 marks, I'll give you 1 mark just for doing this. And 1 mark for that, right? So don't get lost in the wording. Okay, last question. We're going to skip question 6. Give you enough time to do your homework. Okay, this one I really like. This is really important to what's happening right now. Okay, a type of bacterium is known to triple every hour. There are 50 bacteria to start with. How many will there be after each number of hours? So first question is after 3 hours, how many there are? B is 5 hours, and C is actually asking you to come up with a generic equation. So it could be 10 hours, or it could be 20 hours. How do you come up with a formula for determining this?
What does it mean by n?
Yeah, that's what I just mentioned. Generic formula for any given time, right? So we'll come up with this. So if I said we started off with 50 bacteria. After 1 hour, it triples. So how many bacteria do we have after 1 hour? 50. Good. So we had 50. We just times it by 3. It's 150. Okay. How many would we have after 2 hours?
100, like 2 hours after the 3 hours?
2 hours from time 0. So another hour has gone by. So after 1 hour has gone by, we got 150. How many do we have to have after the second hour?
450.
450. We triple it, right? Every hour, it increases by 3. So we go 150 times 3, right? Or if you bear with me, because we want to see a pattern, we have the 150 times 3, and we're going to multiply by 3 again. So we have 150 times 3, which equaled our 450. All right, so after 3 hours, that's what the question asks. How many bacteria do we have? We go 450 times 3, right? So, yeah, so we go what we had before, which was our 450.
So it'll just be 50 to the power of your number.
Yeah, so then we said that was 1,350, right? You guys see a pattern developing?
Yeah.
All right? So you can see that,
Is there no way you can do it in just one step?
yeah, you can. So you go, look at this.
50 to
To be
the
by
power
Q.
of 3.
Yeah. So this could be,
50 times 3 times.
it could be 50 times 3 to the power of 3, right?
Yeah.
And if you wanted to do this one, it would have been 50 times 3 to the power exponent 2. That one would have been just 50 times 3 to the exponent 1. You see the pattern happening, right? That's why I wrote it out this way. It's easier to see the pattern from where the numbers came from, right? Where the hour is equal to the exponent.
And
Right.
would you still get full marks for that?
Yeah, that's what I want you to do.
Okay.
All right. This stuff I could probably teach a grade 7 to do. This is what I want you to be able to do. All right. So if I asked you for 5 hours, how would you calculate that? Instead of having to write out, if you want, you can write out each number you want.
50
50 times 3 to the power of 5, and then
50.
equals 12,150.
12,150. Okay. So that is the answer for B. For C, number of bacteria for any given time is 50 times what?
10.
No,
50 times
3
the power.
n, whatever time you're looking for. All right.
Well,
So-
you can put whatever time you want on top of
Yeah. So if you're looking for in 100 hours or 200 hours, that's what you do. Yes.
So the exponent would be the variable.
Yeah, your exponent is your variable. Now, this is a slightly simplified formula, but with everything that's going on with COVID, you know how you hear about flattening the curve? They're using a formula like this. If you graphed this formula, it would go something like this. These are called exponential curves. Everything, all the exponents we graph, they all go like this. All right? And so when they're talking about flattening the curve and they're talking about that R value, whatever they're talking about, they always go, we want to keep R less than 1. Right? And that R value at the saying less than 1 is how quickly does it double. Right? So what happens is you have your initial amount of your population, how quickly it, in this case, triples, but you can change that to a 2 for doubles. N is your time frame. And they look for how long does it take it to double. We want it long as possible. We want it to be a week, a month, right? If it's doubling every second day, it's going to be out of control because you can see the graph just goes shooting out. The real formula, which you don't really talk about it in grade 10, but you have the basics. In grade 11, you start talking about it. It looks something like this, something like that, where E, you haven't learned this number, is like 2.17, and R is how quickly it doubles, and that's your time, or your how fast it grows. But it's very similar to what you're learning now, and you can understand sort of what they're going for, right? All right, so I think this is a very practical thing for what's going on right now.